Last episode, we met Shaky, the robot that took 2 hours to cross a room. Today, we go backward to the language that made Shaky think. A programmer at MIT reads his professor's paper. The paper describes a theoretical exercise, not meant to actually run. He ignores that. He types it into the machine, and it works. His professor is stunned. That was meant for reading, McCarthy says, not for computing. Too late. The language is alive. John McCarthy had a problem. It's 1958. He's at MIT, and the only language anyone uses is Fortran. Fortran is built for numbers, trajectories, missile calculations. It loops through arrays. It crunches data. But McCarthy wants something else. He wants to manipulate symbols, ideas, logic. He wants a program that can reason about the world. Fortran can't do that, so McCarthy designed something new. Here's what made Lisp different. Imagine you're writing a recipe. A normal recipe says do step 1, then step 2, then step 3. Fortran works like that, step by step, linear. But McCarthy wanted recursion, a recipe that says now follow this recipe again, but with a smaller portion. A program that could call itself, that could think in loops, that fold inward. Fortran couldn't do that. McCarthy's language could. He also wanted programs that could rewrite themselves. In Lisp, code and data look the same. Both are just lists. Lists of symbols inside parentheses. This sounds abstract. Let me make it concrete. Imagine a notebook where every sentence is also an instruction. You can read the sentence, or you can execute it. Same format either way. That's Lisp. Code is data. Data is code. The boundary dissolves. McCarthy had one more problem. He designed an elegant syntax for humans, called it M expressions, clean, readable. But underneath, the machine used S expressions, raw lists, parentheses everywhere. The plan. Humans write M expressions. The computer translates them to S expressions internally. That's not what happened. Programmers started writing S expressions directly. All those parentheses, they found them natural, even beautiful. M expressions died. The internal format became the real language. Organic evolution, not top-down design. Now comes the legendary moment. McCarthy writes a paper. Pure theory. He describes how you could write a Lisp interpreter in Lisp itself, a language that reads itself, interprets itself, the snake eating its tail. He publishes it as mathematics, a thought experiment. Steve Russell reads it. Russell was a programmer working with McCarthy. Young, practical. He looked at the paper and thought, I can make this run. According to McCarthy, Russell compiled the eval in my paper into IBM 704 machine code, fixing bugs, and then advertised this as a Lisp interpreter. Which it certainly was. McCarthy hadn't intended it to be built. He'd written it for reading, not computing. Russell built it anyway. Early 1959. The first Lisp interpreter runs. Theory becomes practice, in one stubborn act of implementation. But the IBM 704 had a problem. Memory, just 32,000 words, tight. And Lisp created lists constantly. Nested lists, temporary lists. Every computation spawned more. In other languages, you tracked memory manually. Imagine a kitchen where after every meal you have to remember which specific pans to wash. Forget one, you run out of clean cookware mid-recipe. Programmers hated this. Memory bugs were everywhere. Russell and the MIT team tried something radical. Garbage collection. Let the machine figure out what's still needed. Let the machine clean up automatically. In fall 1958, Russell proposed it. By summer 1959, it ran. No more manual tracking. The language handled its own memory. Today, every major language does this. JavaScript, Python, Java, Go. They all borrowed from Lisp. 65 years ago. The critics came immediately. Lisp was slow, significantly slower than Fortran. It used too much memory. The parentheses were ugly. McCarthy didn't care, because Lisp could do something Fortran couldn't. It could solve calculus problems. 1961, James Slagle, one of McCarthy's students, builds Saint, symbolic automatic integrator, written in Lisp. Saint takes MIT freshman calculus exams. It solves 52 of 54 problems, performs at approximately the level of a good college freshman. A program, passing calculus, written in a language 3 years old. Lisp should have died. AI winters came. Funding collapsed. Twice. The language kept going. 1995, Paul Graham builds ViaWeb, an online store builder, written in Lisp. His competitors used C++ and Perl. Graham could add features faster than they could. The parentheses that looked ugly gave him power they couldn't match. Yahoo buys ViaWeb in 1998, $49 million, for a program written in a 40-year-old language. Here's what gets me about this story. Lisp is still running. Right now, Grammarly. Billions of sentences checked. Core engine, Common Lisp. When you search flights on Kayak or Orbitz, that's ITA software. Common Lisp. Google bought them in 2011. Still runs the same codebase, a language designed in 1958. Before the moon landing, before the Beatles. Still processing your flight search. McCarthy built something that lasted. Not because it was fast, not because it was easy, because it could think about itself. A program that could read its own code as data, modify itself, reason about reasoning. That idea never got old. Next time, the MIT AI Lab. McCarthy and Minsky build something bigger than a language. They build a culture. Hackers, all-nighters, radical openness. The place where Silicon Valley learned to think.